Do you run Azure Virtual Desktop in your environment and it's costing you too much money? If so, I've got the video for you today. So today we're going to look at AVD cost optimization, right? So we're going to look at all the components of Azure Virtual Desktop. We're going to look at the VM SKU. We're going to look at the auto-scaling configuration. We're going to look at the FSLogix. We're going to look at the log analytics. So we're going to look at these and see how we can optimize and reduce the cost of Azure Virtual Desktop. The most important thing to remember is Azure Virtual Desktop is a consumption-based model. You pay for what you use and consume. So essentially what we need to do to make Azure Virtual Desktop as cheap as possible is we need to make sure we're highly optimizing all the resources, right? We need to make sure we're only paying for what we're actually using, and that's what we're going to go through today. Some of the stuff that we're going to look at today is the auto-scaling configuration, the host pool, the VM SKU type. We're going to look at your FSLogix profiles. We're going to look at disks, and we're going to look at stuff like log analytics as well. So we're really going to go quite deep and see how we can reduce the cost of the Azure Virtual Desktop environment. So I've spent probably the past 4 or 5 years of my career doing this with lots of environments, hundreds. So in today's video, I'm going to share my tips and all the stuff I've done with other customers. We're going to be using a tool called Nerdio. A lot of stuff is applicable outside of Nerdio, right? So don't feel you have to be using Nerdio to do these things. It makes it a lot easier, don't get me wrong, but a lot of the information can also be applied to native Azure Virtual Desktop environment. Okay, so that's what we're going to look at today. So really looking forward to today's video. So please let me know in the comments any questions, or if you've done this in your own environment and seen what kind of results that you've had as well. Okay, so the thing that we need to think about with Azure Virtual Desktop is Azure Virtual Desktop is a Azure service, okay, and with Azure you pay for what you consume. So we need to make sure that we are as highly optimized as we possibly can be. This is what we're going to go through today, and we're going to cover each component one by one. Let's get into it. As I mentioned before, if there's anything that you want to know, please put it in the comments and I'll respond to you as soon as possible. All right, let's get to it. So first of all, let's take a step back and look at the actual architecture of Azure Virtual Desktop. Let's see what components Azure Virtual Desktop is actually made up of, and then I'll show you how you can save money on each of those components. All right, what we're looking at in front of us here is every component that's required for Azure Virtual Desktop, right? And the stuff that costs money, I'll explain what those are. So first of all, we have networking. Networking cost-wise isn't that much. It can be, depending on how you got your network configured. But you need to think about inbound and outbound traffic. As long as you've got your networking configured correctly and everything stays within the Azure subscription, you're good to go. But as soon as you start replicating network traffic across regions, then it can get expensive. Any network costs within your Azure environment, we don't pay for. But if you putting stuff over VPN across a region, it can get quite expensive, something that you definitely need to be wary of. But for most companies, as long as you keep that traffic inside that Azure Virtual Desktop network, you're good to go. Obviously, you don't want lots of traffic traversing your firewalls, because if you're going across your firewall, maybe hosted internally, or your VPN on-prem, and you've got maybe a file share which you're dragging lots of data from the Azure Virtual Desktops, then you need to be a bit careful there. But key tip is, make sure if you've got like high net bandwidth traffic, make sure it sits inside the Azure subscription, okay, and that will keep costs down to a minimum. So the second one we can see here, and we've got these VMs, right? So these are the actual VMs that we're running inside the Azure Virtual Desktop environment. Each Azure Virtual Desktop session host runs as an actual VM, right? VMs cost money. You pay for VM, I pay as you go. Or we could do reserved instance, right? So we'll go into a bit of detail about that when we look at the VM SKU. We could also reduce the cost of VMs by using auto scaling and turn them on and off when we don't need them, for example. Next, we've got your Azure Desktop files. These are primarily used for your FSLogix profiles, right? So again, they can have quite a big cost impact. Storage can be cheap, but it also can be very expensive in large environments. So I can definitely show you some tips and tricks of how we can reduce the cost of those storage accounts as well, and we'll take a look at that. And then we've got Active Directory Subnet as well. That doesn't really cost much. So as you can see, most of the cost that we're going to consume around Azure Virtual Desktop is going to be around the VMs, the storage. So when I say storage, either the Azure Network files or Azure files, or actually the cost of the actual disks on the VMs, and we'll cover that as well. So that's the basics of the VM SKU. And next we'll go into the Azure portal, have a look at those components, just so you can see what we're talking about. And then we'll actually deep dive into each one of those components and show you how we can reduce the cost. All right, let's go. What you can see here is I'm in my Azure portal. These are the basics of AVD session hosts within an Azure Virtual Desktop environment. Let me explain what these are. First of all, we've got the virtual machine. So the virtual machine is what we would use as a session host. Okay, so just click on that and you actually have to see what that is. I have a virtual machine, and so let's see this one stopped and deallocated because I've turned it off because I'm not using it, so I'm not paying any money for this VM. So that virtual machine consists of a network interface, and any cost of the network internal to the Azure subscription you don't pay anything for. And then we've got the OS disk as well. Okay, so the OS disk is part of the actual VM. Each individual virtual machine within Azure has its own disk. So if I go into the VM here, and then if we have a look, we can see virtual machine, we can see networking, okay, and then we can see this disk here, right? So this is the disk that I've got within inside the virtual machine. And then if we click on that, I can see this is the name of the disk, and you can see this is the storage type, which is set to standard SSD, and we can see the number of IOPS that we've got, and we can see the max throughput for that disk as well. All become clear later, don't worry too much about that, but we'll go through in detail and show, okay, how can we cost optimize this a bit more as well in the future. And then we've got our host pool. So this is the host pool configuration we've got, and then we've got what we call an app group, which we assign to the users, and then we've got a workspace, a storage account. So the storage account which stores the FSLogix profile. We need to think about the cost of this, because we can cost it depending on whether you're standard or premium. But okay, we'll go into that a bit more detail soon as well. So we need to make sure this is all optimized, and we can look at recommendations from there as well. Okay, so that's the basic architecture that we're going to use within Azure Virtual Desktop, and we're going to show you how to cost optimize each of those components one by one. All right. So now we're going to look at what is probably one of the most important decisions around your Azure Virtual Desktop environment, and it will determine the cost essentially. One of the most important ones is the actual VM choice, and this is probably one of the most typical mistakes that I see customers make. We have lots of different VM SKUs within Azure. So the first one is the D series. So generally, D series is what we call our generic type of virtual machine. Okay. Each virtual machine, the choice that you have to make is the amount of processors or vCPUs, and also the memory. Okay. So obviously the number of vCPUs and the number of memory determines how many sessions that we can get per host. And that also determines how many hosts we have. So you can see this has quite a big cost impact in your environments. If you get this wrong, it could cost you a lot of money. If you get it right, it could save you a lot of money. So let's take a step back and look at what are the different VM types. The first VM type is what we call a D series. So that's generic. Right? So if we talk about ratios, I'm going to say this is like a 1-to-1 ratio. So we've got equal amounts of memory and CPUs. For example, on a D4, we will have 4 CPUs. So D series is the actual series of VM. 4 is the number of CPUs, and then it'll be like a D4 16. That will have 16 gigs of RAM. When we move on to a different series of VM, that ratio changes. We would normally see an E series VM. The difference between D series and E series VM is the E series is optimized for memory. So whereas the D4 16 may have 4 cores and 16 gigs of RAM, a E16 will probably have 16 cores and 32 gigs of RAM. So it has double the memory, so the ratio is 1-to-2. All right. So why does this matter? This matters because generally what we sometimes see with workloads is they'll have very low CPU usage but high memory usage. Right. So if I've 4 users on a session host, they're using like 10% of the CPU, but they may be using like 90% of the memory. That means I can only fit a maximum of 4 users onto that session host. All right. Now, if I then switch that VM over to a E series, okay, I go from 4 CPU, but I've got double the memory, so then I may be able to fit maybe 8 users or 6 users onto that session host. Okay, so the cost will be just a little bit more, maybe 20% higher, but it means I can actually fit double the number of users onto the session host, and therefore that's going to massively reduce the cost of my VMs. Right, so take that into consideration. We normally look at the utilization of the CPU and the utilization of the memory. If we see low CPU usage but high memory usage, that essentially means that I need to switch my VM series over to an E series VM. Okay, and the opposite works as well. So if we're seeing lots of high CPU usage and we're seeing lots of low memory usage, maybe we can look at something like an F series. It's a balancing act, right? But the goal of the game is to try and basically get the CPU usage and the memory usage high, right? So I try to aim to like 75 to 80% both CPU and memory, and that means we're highly utilizing the host, so we're cost efficient with those session hosts. So let's just have a quick look and see what that looks like within the portal, then also show you what it looks like within the Nerdio console as well. You can see here with the Azure Virtual Desktop pricing calculator, so you can see here I've got the D4 SV5, and then in there I've got like 16 gigs of RAM and 4 CPUs. If I then do a E4, what's it easy? E4. So you can see here I've got all the different SKUs. So you can see how the E4 series has got 4 CPUs but 32 gigs of RAM. So this is what we need to think about when we're looking at the sort of VM SKUs and whether we need to optimize the utilization of those VM SKUs. The other thing we need to think about when we're looking at the cost is the actual hours that those VMs have been used. So you can see here, so if I pick a D4 SV5, right, so maybe I'm going to pick 10 virtual machines in here. So you can see here my monthly cost is US $2,900 a month, and I'm running those for 730 hours a month, right? So that means those VMs are running 24/7. What if I wanted to do auto scaling, right? What if I wanted to switch those VMs off? I can turn around and say, I'm going to switch those for maybe 250 hours a month. So you can see the cost has gone down to $1,000. So that's massively reduced the cost of those virtual machines. And if we then say maybe 400 to 624, you can see we play about these figures based on the hours, right? So that's definitely something we need to think about. How many hours of those VMs been used? Okay. So next we're going to look at when it comes to actual VM SKUs is these things called saving plans and reservations. So let's see what this difference is here. So if I go into reservations, a reservation is if you pay upfront essentially, right? So if you know you're going to have a guaranteed workload, we can basically go in here and say, okay, I need these VMs 24/7. So I'm going to put it here, I'm just going to put that back to 720 hours. So you can see there the cost is $2,923 a month, right? It's 720 hours for 10 virtual machines. So if I turn around and say I want to do like a 1 year reserved instance for those VMs, I click that. I want to do it monthly, and you can see there the cost is $2,229. So not a huge amount of saving to be had, but if we turn around and say I want a 3 year reserved instance, that cost goes down to £1,942. Now, I see a lot of people make the mistake and say, yeah, that's cheaper, let's go for that. If we don't need that workload 24/7, right? So maybe we're only running those VMs like, I don't know, 5 days a week. So I only need those VMs for maybe 240 hours a month. My cost is now $974, right? So I'm actually spending more money by doing reserved instances compared to auto scaling. But what we commonly see is maybe they'll have 1 or 2 VMs running on reserved instances, so you got that consistent workload, someone can connect to the host port 24/7, and then we'll do rest on page you go, right? So we'll show you how to do that within the Nerdio calculator later as well. I mean, reserved instances save you money, but only if you need that workload 24/7. Okay, otherwise it's actually going to end up with you costing you money. Next decision point is the disk. Okay, so as you can see here, and we've got different disk SKUs that we can use. So we can use standard HDD, we can use standard SSD, and we can use premium SSD. Premium SSD version 2 you can't use as the OS disk. I'm sure that's coming later, but for now we'll just concentrate on what's the difference between these. There's basically down to performance and also the SLA. Okay, so if I click standard SSD, you can see, let's pick 120 gig disk. You can see the cost of that is $6 a month. Okay, if I then switch that to standard SSD, 228 gig, we can see that goes to $10 a month. Okay, so quite a bit more expensive. And then if we switch that to premium SSD, that goes to $23 a month, so even more expensive. So if we think about the cost of the first one, like $6 a month versus $23 a month, that's considerably more expensive. And again, if we go back to our example, we've got 10 disks in there, it's like $238 a month. And if I switch to premium SSD, a standard SSD, and that takes it to 105, double the cost essentially. What factors do we need to think about when we can get the cost of the disk? It comes down to what applications are running on those VMs and how many users we're getting on those VMs. With single session desktop pools, we sometimes can get away with standard SSDs. So the difference is the throughput. I'll display it on the screen, the differences between the throughputs and performance, but essentially the bigger disk is, the more performance that you're going to get. And the differences between a standard SSD and a premium SSD is burstable IOPS and throughput as well. So I have heard from multiple customers, I normally recommend using standard SSD for single session desktops, but customers do tell me it's like the difference between standard and premium, customers really know, right? They can really feel it. So if we talk about the cost difference between standard and premium, so if I go that, say it's 105.60 versus 238, so it's quite, per month, it's quite a big cost difference for 10 VMs. Just one VM is probably not that much. So if we look at the cost of one VM, so standard SSD on a 120 gig disk is $10.56, whereas on a premium SSD it's $23. So it's like $10 a month. If you're cost conscious for single session desktops, I would always use standard SSD. But if the user performance really is important to you, then you can use premium SSD. For multi-session host pools, I always recommend premium SSD purely because of the performance difference. You can see here, I've got 500 IOPS. It's burstable, right? And the bigger the disk is, and the more IOPS that you get as well. If IOPS is important to you, sometimes we see customers over provision those VMs to get the IOPS they need. But for multi-session desktops, 120 gigs is enough. Sometimes customers go to 256 because when we think about IOPS, the average IOPS per user, depending on application, is around 50 IOPS upon logon, and between 5 and 10 IOPS in steady state. So if we think about we've got 10 people logging onto a session host at the same time, we're easily going to consume 500 IOPS. So sometimes we do have to up it to 256 just to get the performance that we need from that disk. But yeah, need to think about that. But the other thing to think about as well is a tool like Nerdio. We can actually switch the disk from premium SSD to standard SSD when the VM is not running, right? And that gives you considerable savings as well. So we can go into that and look at that in a second when we go into the Nerdio console. Okay. So yeah, from a VM perspective, that's pretty much the only charges that you're going to get. The only thing to think about is the VM SKU. You pay for that only when the VM is running. The disk, you pay for that consistently. That's the other thing to think about as well. And then we've got bandwidth as well. So if the bandwidth stays within the region, or we've got internet egress, right? So if I go to into region, there's zero cost, right? If I go into egress via the Microsoft Global Network or the public internet, you can see there that can add up 5,000 gigabytes, which is 5 terabytes. That'll cost you like $392 a month. If you're putting a lot of traffic through there, that can easily get really expensive. Be careful around how you've got your networking set up and configured. That's the basics of what you're paying for from a VM perspective. And now we're going to look at the host pools. Okay, what kind of host pools can we pick and how that affects the cost of the environment. All right, so now we're going to look at the different host pool types, right? So this is also a very critical decision in proving the cost efficiency of your AVD environment. The type of host pool that you create massively affects your cost. So let's walk through what those different types are, and then we'll go into comparison around how much they cost. All right, so in preparation for this, I've actually gone ahead and done some modelers, right, with all the different host pools. My basic configuration is I've got 1,000 users and they're working 9 to 5. So this is quite a simple configuration. In reality, you could probably get further cost savings because not everyone works all the time. A lot of people will use the desktop for like sometimes 2-3 hours a day. For this modeler, I put it to use it for the desktop light for 95. Okay, so first type we've got something called multi-session host pool. A multi-session host pool is where we have a single session host or multiple session hosts sharing lots of sessions, right? So rather than having one user log onto one VM, we may have 10 users logging onto that one VM. So we're sharing that session host. An advantage of this is obviously it's a lot cheaper, okay? And because we've got multiple people using the same resources, right? So we're sharing that cost amongst those users. As you can see here, I've got 1,000 users. The total cost of that is $11,000, okay? So basically for this configuration, what we've done is we've got a multi-session host pool. We have 2 users per vCPU. So Microsoft will tell you 4, but in reality, it's going to be about 2, sometimes 1-to-1, and depending upon the applications. And you can see here we've got a D4 ADS V5, and we're using premium SSD as we discussed earlier. And then the stock dose type is going to be standard HDD. We're just using a marketplace image for this calculation. And basically, I've got Monday to Friday, 9 a.m. to 5 p.m. and I've put 50% users absence, right? So this means maybe the host pool is being 50% utilized. Obviously, each workplace is different. Some people will work 100%, like 9 to 5. Other people, like shifts and stuff, it all depends. I'm using 50% for baseline because that's generally what I see out there in the wild. And then we're using FSLogix profiles, and I put profile size of like 30 gigs per user. And this is basically what it's pumping out, right? So it's basically showing me, hey, Nerdio, obviously you can do this without Nerdio. It's $11,000 optimized. If you weren't using Nerdio, it would be nearly $40,000. So you get 70% cost savings. Again, is what I see out there. And we're looking at a per user cost of around $11 per user. Unoptimized, we're looking about $39 per user. You can see there, and we've got all the different cost savings for the disk as well. Then if you want to secure advanced details, it basically just tells you what is calculated, how many hosts that we need. And so you can see there it's calculated for 1,000 users, and we need around 63 session hosts, which, yeah, again, I think that is about right. Okay, all right, so that's multi-session. And so let's go back to that. So basically, that I'd say most of the customers I work with, multi-session seems to be the most popular one because it just offers so much flexibility, right? And the cost can be quite low, you can see there. And we've got a per user cost that's $11. Generally, I see that between $15 and $20 per user. I mean, it's generally the average that I see there. In an unoptimized environment, that may go up to $30, $40 per user, but we try to get it down to $15 to $20 per user. Next one I'm going to go through is something called single session. Single session is when each user gets their own individual virtual machine. So that's a one-to-one mapping. If I've got 1,000 users, I need 1,000 machines rather than like the 63 session host that we had. The total cost of this is going to be $30,000 compared to $11,000, right, of a multi-session host pool, and therefore we're getting a per user cost of around $30. So yeah, to me that sounds about right. And we're not using those VMs 24/7, so we can use the native auto-scaling to do that, or we can use the auto-scaling mechanisms to do that as well. Okay, I'm not going to go into detail on that in this video, but just want to give you a very high level overview of the different options that are available to you. The next one we go to is something called a bit of a mixture between the two. It's something called single session pool. And the way single session pool works is you have a bunch of single session VMs. Each user still gets their individual session, but it's not a one-to-one mapping, it's a one-to-many. And what that means is I need a minimum number of VMs running, because if I've got only, say, 500 users working that day, I'll only need 500 VMs running rather than 1,000 VMs. So it can massively reduce the cost as well in a single session. It's also good for developer use cases because each individual user gets their individual VM, and that will give you an average per user cost of around $20, which is pretty much bang on. And you can see that's considerably cheaper than using a single session. So $10,000 a month saving from there as well. Okay. Next one is something called remote app. So a remote app is where a user doesn't actually get the full desktop session. They would just get a application. So if you've got an environment where you just have a small number of applications running, so maybe like 1 or 2 apps that you're using, maybe SAP, or maybe it's a industrial application or something, it can be a lot cheaper to run it as a remote app. And the difference being is if I'm a user or if I'm a desktop, I'm using minimum like 2 gigs of RAM for that desktop session and maybe 10% CPU. Now, with here, we can turn around and say, I just want a remote app. So that may only consume like 1% of memory and 10% CPU or 5% CPU. So you can fit a lot more users on there. So on a D8, for example, I maybe have to, I don't know, 8 or 10, 12 users on there. Whereas if I'm just using a small remote app, and maybe I'll fit 50 users on there, right? And so we're squinting a lot more users on, and therefore the cost is much lower. So you can see here, again, this is just an average. I've got like total cost of like $8,000, and therefore I've got a per user cost like $8, right? So that's just if you're using a remote app. This is why it's crucial to determine what host pool type you're using, because it can have a big impact on your cost. What we generally see out there is a mixture. It's people who need the performance of a single session desktop, they'll have a single session. And for those people who are just Office generic workers, like they're basic, like creating Word documents, Outlook example, they'll sit on multi-session. And then we may have a couple of remote users as well. I think just a mixture of what makes the most sense for your business. And then to lastly, we've got Windows 365, right? So Windows 365 basically is not consumption based, it's subscription based. So we pay for that license. So here we've got 1,000 users, and you can see, and this is the most expensive one. We've got $31,000 because we're paying like $31 per license for that. We do have different license types now, and we have like frontline shared mode, so that can reduce that cost as well. So Azure Virtual Desktop, consumption based, Windows 365 subscription based. That's the difference. I just wanted to add in there just to give you the cost comparison. This is why it's critical that you pick the right host pool configuration, because it can have quite a considerable impact on your costs. So the next thing I want to talk about is host density, because that can actually have quite a big impact on the cost as well, right? Obviously we don't want 100 session hosts with 1 or 2 users on each, so we need to make sure that we're filling up those hosts. Now, how can we do that? So let's take a quick look at a typical example of what we see out there. So this is a snapshot view from Nerdio, and what we can see there is we can see the CPU usage. Okay, this one is the memory usage, this one is the active users, this one is the CPU usage, this one is the memory, this one is the total number of users, and this one is the active users, right? So what can we tell from this graph around optimization? The CPU usage is pretty low, right? We're never really going to like 20-30%, but the memory usage is quite high, right? So this is a typical scenario where we're not really pushing the host to its limit, because we've got low CPU usage but high memory usage. So this is a classic candidate that you want to switch over to an E series, because for this VM SKU, if I was switching over to an E series, I may be able to fit an extra, I don't know, 10 sessions on that session host, okay? And therefore, the cost of that will be much lower. I want this number to be at least 50%, ideally 60, 70, 80%. So for me, a perfectly optimized session host is where you are using all the available resources to get the maximum number of sessions per host, and therefore your costs are going to be much lower, right? Because we either need less hosts or we need more optimized hosts. Okay, hope that makes sense. So the next thing we need to talk about is depth first versus breadth first. What does that mean? So essentially, with Azure Virtual Desktop, there's 2 different load balancing methods. There's breadth first versus depth first. So imagine you got 10 session hosts in your environment. Breadth first spreads the load amongst those 10 session hosts. Okay, so if I've got 100 users logging onto the host pool, user 1 will log on to host number 1, user 2 will log on to host number 3, user 3 will log on to host number 4, 5, etc. If we switch it to depth first, that's going to bunch the users up onto the session hosts, right? So if I've got host number 1, which has capable of running 10 users, we will tell it we want maximum of 10 user sessions per session host, okay? And then what we'll then do on this, okay, let's switch it to depth first. The first 10 users will log on to that first session host. So we're utilizing the hosts a lot better, okay? So rather than having 10 session hosts running with 1 session on each, or maybe 1 or 2 sessions on each, we maybe only need 2 or 3 session hosts to compensate for that workload. Now, there are downsides to this, and the biggest downside is performance. If all my users log on to the host at the same time, if it's like a call center scenario, so performance can suffer. And maybe I've got 1 or 2 of those users which is using a lot of CPU or memory. Okay, that means I've got 9 other users on that session host, and they're going to suffer and have a bad experience. Whereas if we're spreading a load out amongst those 10 session hosts, it basically means that we're less likely for that to happen, and the users will generally have a better experience. But the downside to that is obviously cost, right? So how can we fix it? Let me show you what that actually looks like. So here's a good example of how a badly optimized environment. You can see here I've got a number of session hosts, CPU utilization on the left, memory utilization on the right. Okay, so we can see here basically the CPU utilization is low and also the memory utilization is low, and I've got 5 sessions per session host. So this is a typical example of breadth first. Now cost wise, this is very bad, right? Because it's potentially costing you double what it should. I could probably work with half the number of session hosts. I could easily fit like maybe 10 sessions per host, and therefore I can reduce the number of sessions that I need per host. Okay, so this is why it's really important to start using your host as much as you possibly can do, because it essentially means that it's going to massively reduce your costs. This is probably one of the most popular things which you come across in customers' environments, and the way we fix this is we can do 2 things. I normally reduce the number of available session hosts. If I'm turning on 20 session hosts, for example, I'm going to log on to all those 20 session hosts. But if I only turn on 10 session hosts, I'm going to fit more users per host, and therefore we're going to utilize this host a lot better. The other thing we can do, and we actually release a new thing within Nerdio where we can actually switch from depth first to breadth first during the time of day. So that's another thing you can do to reduce the cost of it. But the easiest way to fix this is to reduce the number of session hosts that are available in the host pool. Because say if we're using breadth first and we're like 50 session hosts, then we're going to use all 50 session hosts. Okay, hope that makes sense. But yeah, this is definitely a top tip, and it's something we see often when reviewing customers' environments. So the next thing I wanted to show you was how to optimize your auto scaling configuration, because this will have a big impact on your costs. So we'll do it for multi-session pools and single session pools. Now I am going to use Nerdio to do this, so that's the tool I recommend if you want to optimize your cost configuration, because it can massively reduce the cost of your environment. So let's do a walkthrough of how to optimize the host pool using Nerdio. So I'm in the Nerdio console. Okay, so first thing we need to look at is how many users per host. Generally, to get that number, we look at how many users vCPU, how much memory we're going to use, that type of thing. I'm going to select 10, for example. And breadth first is depth first. We'll discuss that later in the video, but this means how quickly we're going to fill up those session hosts. Most customers use breadth first because it gets the best performance, essentially. But if you're really cost conscious, you can look at depth first. Base host capacity, so this is the amount of users that we need per host. The way I work this out personally is I work out our users per host. So if you're telling me we need 100 users, I need 10 session hosts. If I need 400 users, I need 40 session hosts in there as well. So this is the base host capacity, so it's the minimum number of hosts that we need created, not powered on. And then we've got a minimum active host capacity, so this is the amount of users that we're going to have this is the amount of hosts that we're going to have powered on at any one time. So normally people pick just 1 or 2 session hosts, and they'll have that session host on a reserve, so that VM is running 24/7. Now this is the most important bit here. So what we've got is we've got these triggers, so we can have CPU usage, RAM usage, AVD active sessions, available sessions, or user driven. And we can pick CPU usage, right? So we're going to power host on and we're going to power off based on the CPU usage. We can pick RAM usage, or we can pick average active sessions, or we can pick available sessions. Available sessions is probably the most common one customers use. So essentially I'm going to say always maintain 10 available sessions, right? So it's going to have 1 host spare all the time, and therefore we're not going to have any issues with people logging on, but we're always going to use the minimum number of session hosts running. You can also use multiple triggers. The important thing about this is what we're using to tell Nerdio to power host on and off. So this is going to have a huge impact on your cost as well. Let's pick available sessions. I'm going to say I always want 10 available sessions. When do we want host to power off? And we're going to also pick the scale and aggressiveness. So I can say low, medium, or high. I'm only going to turn host off with no users on them. Medium, I'm going to turn host off with no users on them, or people in a disconnected state. High, I don't care, I'm going to switch the host off. Okay, so we can also select the time, so we can say stop or remove host only from, maybe you don't want to switch host off during the day, so I can say right from 6 p.m. till 5 a.m. for example. I want to make sure I'm not switching off any host during the working hours to affect user sessions. That's really important. And then we can also do something called rolling tray mode. Yeah, at maybe 3 p.m. in the afternoon, and when the users start to drop off, I want to switch it to depth first, and I want to put the aggressiveness to high, and then I want to put 50% of the hosts into tray mode. So that really helps get the users off the platform quicker, and it means any sessions which come onto the platform after 3 p.m. They're going to go onto the remaining hosts in the session in the host pool, and therefore we can switch those hosts off a lot quicker. Another top tip as well is to use something called pre-staging. So imagine I've got 40 hosts in this host pool, but maybe we only need 20 session hosts, right? And maybe there's only 10 times 20 users coming in. So I can turn around here and say, right, Monday to Friday at 8 a.m. I want to have 20 hosts powered on. Okay, and keep those powered on for 2 hours, and then if no one logs onto them and uses them, then we can just shut those hosts down. What this enables, it enables us to get maximum performance because I'm getting those hosts ready. I'm not relying on the auto scaling to wait to power those hosts on, so it gives the host a bit of time to power on and calm down. But it also means that I can calculate quite accurately how many hosts I need. Some people just turn on 40 and you're only using 50% of the capacity, but if I know I can fit 10 users onto a session host, and that's maximizing my memory utilization, I'm going to say I need 10 users per session host. I've got 100 users, therefore I need 10 session hosts. Okay, and that will power on 10 session hosts for me, so I can quite accurately predict what that workload is going to be. So that's for multi-session host pools, and this is a really good way of optimizing your costs because we're only powering on the minimum workload that we need, and therefore we're going to optimize our costs rather than just provisioning, guessing essentially how many hosts that we need. Alright, so the next one we're going to do is for single session host pools. So for single session host pools, we've got two types of auto scaling. We've got something called schedule based, so we can see there Monday to Friday 8 till 6 p.m. I'm going to turn on my hosts in my host pool, so we can set something called power off aggressiveness, power on timing, and power off timing. So essentially what we can do, the power off aggressiveness, it means only those desktops VMs that do not have active user connections, including those with disconnected sessions. Is that at the end of the working day, if there's no active sessions on the user, what this will do, this will power off the desktops that don't have an active user session, including those with disconnected sessions after this time window, right? At 6 p.m, if no one's using these VMs, it's going off. If you want to kick users off single session desktops, power off all the desktops, including those with active and disconnected sessions. Users with active sessions will be sent a message given time to log off before the VM is powered off. Okay, and then we can do the same thing with power on. So we can just power it on once at the start of working hours, so that will be powered on at 8 a.m. We can set that to never, which means the VM will never be powered on, and so the user must manually power on their desktops using start VM on connects. And then we can do continuously, which basically means after, and then we can do continuously, which means all desktops will be powered on at the start of working hours. During working hours, AutoScale will automatically power on any manually powered off desktops. So even if the desktop's powered off, they will still be powered on. And then we could do something called auto grow and auto shrink. So auto shrink is probably the best cost saver. Basically, if no one's logged onto the desktop within X amount of days, so I can figure that to 15 if I want to, and the desktops will be deleted essentially. So that can also be a big cost saver, because you're deleting your unused resources. And the next one is something called user driven. So this can also be a big cost saver. User driven basically means that we use start VM on connect to power the host, and then 10 minutes after the user's logged off, the VM will shut down. Right, I can change that to an hour if I want to, and but we can also pre-stage the disk, pre-stage the host. So using this, what I can do is Monday to Friday at 8 o'clock, I'm going to power on all the session hosts. I'm going to wait until 10 o'clock, and then for those desktops that have not been used, they'll just get shut down. And this enables the user experience because it means that any user who tries to log on between sort of 8 and 10 a.m. they'll get an instant connection to their desktop without having to wait for the VM on connect. So this can also be a huge cost saver as well, right? Some companies, they may be running their desktop workload 24/7, or they may be running all the VMs, turning them all on at 8 o'clock in the morning and then shutting them down at 6 p.m. If you're doing that and no one's using the desktop, you're wasting money, right? So we need to make sure that we're using the right method to make sure that any desktops that's not being used, even during the day, to save on cost resources. All right, so we're in the Azure console. I've got Azure files and we're on premium, so I'm not going to show the cost of standard. If we're provisioning 5 terabytes, which is 5,000 gigabytes, we are going to be paying $800 a month. So you can imagine if you've got more than that, maybe $8,000 a month that you're using for your FHLG profiles. Imagine a scenario where I've never cleared it out, I just keep on growing. I'm paying $8,000 a month for file storage space. And then we come in and say, we need to delete this data. So we need to delete unused profiles. As I mentioned, this is something I never see people do. There are various scripts out there. I've got a copy of a script I can send to you. What we can do is clear out all the profiles and reduce the size by this amount of data. I've just shaved off nearly $200 a month. And so that's how easy it can be to save money within Azure. So that's over $30,000 a year you could potentially save just by running scripts, right? So definitely have a look at that. But yeah, top tip, always use premium storage and always clear down the data, because you are paying for what you create, not what you consume. Okay, so recap what we covered so far. We covered the VM costs, we've covered the local disk cost, the managed disk, we've covered the host, we've covered host density, and we've covered the profiles. And so they're essentially some of the core costs that you have within your Azure Virtual Desktop environment. So it's actually quite simple. And as I mentioned, the more users come on the platform, the more it costs you. The less users come on the platform, the less it costs you, right? So the key is to get highly optimized. The last one is something which I very rarely see done as well. So we're going to look at this, and it's basically something called log analytics. Log analytics is the way that Azure collects data, right? So we're going to use log analytics to collect service data. So you'll know it when you're looking at your Azure Virtual Desktop session data. You can see it within the portal. We can also collect it for session hosts. So we want to look at metrics for performance and utilization. We can actually massively reduce the cost by optimizing the mix that we're going to collect. Okay, so let's go and have a quick look and see how we can do that. All right, so we're in the Nerdio console. You can do this outside of Nerdio console as well. You can do it in the Azure portal. So first thing to think about is the retention period. By default, this is set to 30 days. Some people want it longer, so you can set it to 31 days, 60 days, 120 days, whatever. But obviously, the more you set it, the more it's going to cost. Okay, and so what we're going to do is we're going to look at what's been collected. Okay. So this collects all the performance data for these session hosts. So we can use this to track like performance data historically and reporting. Some people just turn it off completely, right? If you're not bothered about collecting the data, I don't know why you would not be doing, but if you're really cost conscious. But you can see here the ingestion cost is $2.88 per gigabit. Retention cost for my environment at the moment is going to be 13 cents, because this is quite an empty environment, because it's a brand new environment that I just built. But typically in customers' environments, I could see the log analytics costs. Sometimes it's a couple of $1,000s. In really large environments with 6,000 session hosts, I could generally see it between $10,000 sometimes a month. But what we can do is we can actually edit the retention, right? So we can say, I only want data for 30 days. So if you've got this set to 120 or 90, definitely take a look at this. But the biggest saver is actually the counters. Okay, and so from here I can see what performance counters are being collected, and they will actually show you what percentage of those counters is made up of the cost. You can see here, this counter here, use it input delay per process, is taking up like 82% of the cost environment. So I can remove it completely if I wanted to. But for example, I'm going to set that to 360. One second. Set that to 360. And Nerdio will actually tell me the cost that will go down. And you can see that this is my dev environment, but in a production environment, sometimes when I run this, I save maybe, I don't know, $1,000-$2,000 straight away just by a few clicks with buttons. Definitely worth looking at your log analytics costs and optimize all of these. We've all got some presets you can set, like low, medium, high, so I can set that to low. For everything, it's going to show me again how much money I'm going to save from that as well. Have a look at that. It could massively make a difference to your Azure Virtual Desktop costs or your total bills. That's pretty much all the costs that are involved with Azure Virtual Desktop. It's not actually that much. So let's recap quickly about what we've discussed here. So Azure, consumption based, you pay for what you use. We need to make sure we are optimizing our resources as much as we can do. From an Azure Virtual Desktop perspective, that means a couple of things. Number one, make sure we're using the correct host pool type. Number 2, make sure we're using the correct VM SKU. You want to be using 50% at least of the CPU and memory. Number 3, make sure that we're using the correct FSLogix profile type and we're clearing down our profiles. Critical. Number 4, making sure we get the correct number of users per host and we're getting host density right. Okay, that's also critical. Number 5, make sure that you are optimizing our log analytics storage, and because that's also can add up quite considerably. If you do all of those, I guarantee your Azure environment will run a lot more optimally. Your financial director, your CFO, I'll definitely be happy with you. But I've done this hundreds of times, and sometimes we shave hundreds of thousands of dollars per month off the cost of someone's Azure bill just by looking at all this and making sure all this is running right, and making sure the hosts are getting powered down when they're not being used, making sure we're using the right number of session hosts. It really is critical within your environment that we get your cost down as much as possible. Thanks for watching, and I'll see you next week. Goodbye.